Hello students, welcome. This is another video which will help students to understand the concept of the chain rule. And if you have any question at the end of this video, please leave the question as a comment below the video. Please don't forget to subscribe, like and share. Let's begin by looking at the power rule. The power rule. The power rule helps us understand that when we differentiate a constant or a number or a function, let me say differentiating something like u to the power n, we are going to have n u to the power n minus 1. Let's look at a few examples. For example, number 1, we have y equals to 2x squared, which implies dy on dx is equals to 4x to the power 1. Why to the power 1? Because using the power rule, the power has reduced by 1. Looking at the second example, we have y equals to 3x to the power 3, which implies dy on dx is equals to 9x squared. Same thing here, we applied the power rule. It looks simple, right? So just following the power rule, we can be able to solve this. And note, anywhere you see an x being written using a red pen, know that the x represents times, like here. Okay, with this we have y equals to ln x to the power 7. Dy on dx will be equals to 7 ln x to the power 6 times differentiating what is inside, which is ln x, we have 1 over x, and our final answer will be equals to 7 ln x to the 6 over x. You have to also know that when you are differentiating something, for example, if you're given a equation like t equals to 2x, it won't be dy on dx at that point in time, but rather it will be dt on dx. What the equation is mainly equated to is what comes first. For example, here we have y equals to x to the fourth, and so we have dy on dx equals to 4 to the power 3. Here we have x t equals to 2x, and differentiating that, we will have x equals to, we have dy on dx equals to 2. Entering the chain rule proper, it works in a similar manner as the power rule, but it helps us, to better apply the power rule. The chain rule has a formula given as d on dx of a certain equation or function f g of x. When you differentiate it, what you have will be equals to f prime g of x times g prime x. Why g prime x? Because when we differentiate f first, we follow by differentiating what was inside. Okay, you need to know that when you're given a question, some books will use according to this formula, some books will take f to be u and some will take v to be g. That is why I gave it as something to note. Then coming to the second formula, which is still part of the the formula for a chain rule, it helps us. If you look at the formula I gave for the power rule, it's same as this formula as the second formula, but it helps us to understand the concept that when we differentiate the outside, we are supposed to follow by differentiating the inside. That is why we have n u to the power n minus 1 times u prime. For example, we are given y equals to 5x plus 1 all to the third. And one thing we can do here is to differentiate following the formula I've given, the second formula. If you're following the second formula, you see that you have, I didn't put it down, but if you're differentiating it, you can come to the final answer here, where we have dy on dx. You will see that dy on dx here is equals to 3x, that's applying the power rule, times 5x plus 1 raised to the power x squared. Oh, there was a mistake in here. We're supposed to have 5x squared, but I didn't put the squared. That's a mistake made there. So you can correct it in your books. Times, differentiating the inside now, you see that when we differentiate 5x squared, according to the first equation, where we are differentiating 5x squared, will give us 10x. So the final answer here will be 10 times 3, which is 30, 30x due to the x here, times 5x squared plus 1 all squared. Let's look at some trigonometric functions. You need to know that these are things you're supposed to know in your head. You need to have in your mind, because you apply in several places while solving question concerning differentiation and all the like. Okay, note that when you differentiate sine x, you could have cos x. When you differentiate cos x, you will have minus sine x. When you differentiate tan x, you have sec x. Sec square x, sorry, I mean sec square x. When you differentiate cosec x, you have minus cosec x cot x. When you differentiate sec x, you have sec x tan x. When you differentiate cot x, you have minus cos x minus cosec square x. You need to, looking at this, you can see that all those starting with a c, when you differentiate them, you have a minus sign. Take a look, cos x has minus sine x, cosec x has minus cosec x cot x, and cot x has minus cosec square x. So when you differentiate, that's a way, that's a let me say like a mnemonic. You just have to put in your mind, or let me say something that can help you to remember when differentiating, that most of those starting with, all those starting with c, when you differentiate them, they have a negative. Let's apply some of the functions we have just seen. Okay, find dy dx for the following questions. Question 1. Here we are still applying the chain rule. Question 1, we are given sine 6x. First, differentiating the outside, we have cos x, because when you differentiate sine, you have cos x, times 6, because when you differentiate 6x, you have 6, and our final answer will be 6 cos x. Coming to the second one, we have cos x squared, and differentiating cos x squared, we have cos sine minus sine x squared times 2x. The 2x comes from x squared. That means when you differentiate x squared, you have 2x, and our final answer will be minus 2x times sine squared x, sine x squared. Remember I said wherever you see an x written in with red ink, it means times. Coming to the third one, we have tan of x to the third, which is equals to sec squared x to the third times 3x squared, and our final answer will be 3x squared sec x cubed. Okay, the fourth one, we have sine 5 sine to the fifth tan cos x cubed, which can also be written in this form in order to make the solving easier. You can write it in this form, that is, the 5 on the sine, the outermost sine, you can take it to be multiplying all through. Take for instance, when you're given an equation sine x all squared, you end up having sine squared x. So it applies same here. If you have sine tan cos x cubed all to the fifth, will be same as sine to the fifth tan cos x to the third, and that helps us to easily solve our question. And applying the power rule here, we have 5 here, which is the 5 we have brought down, and sine tan cos x cubed to the power 4, whereby applying the power rule, it is n minus 1, and our n was 5 times cos, differentiating sine here, we have cos. Then we copy back the inside, and coming here, we differentiate tan, we have sec square, and we copy back the inside, and coming here, we differentiate cos x to the cube x to the cube, we have minus sine x to the cube. Then from there we differentiate the outermost one, or which is sine x to the cube, and we have 3x to the cube, 3x squared, I mean to say. Thank you for watching. Please subscribe, like, subscribe and share for more videos. Thank you.